In the early 1900s, Wilson golf balls were made in Humboldt, Tennessee, and I got to visit the facility, which closed in 2007. It was my first time in a consumer goods manufacturing facility. I remember the curing of the golf ball cores, molded ball covers being ground and painted, and large quantities of finished products, including 2 and 3-piece balls. At the time, many 3-piece balls would use wound rubber thread. In a past video, we talked about the property improvements when natural rubber is stress-induced crystallized. As a kid, if you removed the cover and cut some of the wound rubber thread, the ball would fray into a bird's nest. At the plant, I saw the injection molding process, making golf ball cover halves using Surlyn from Dow DuPont. The injection molding machines were large and complex, and at the time, I knew very little about the process. Welcome back to another episode of Polymer E-Club's Ask Dr. Paul. Today we're going to highlight the injection molding of thermoplastics. So when your boss says injection molding, what do you need to know? A person could learn injection molding through the internet or through book learning. Here I have the 1100-page injection molding handbook, or through seminar learning, maybe a 3-day seminar with flight, hotel, and transportation costs. Polymer E-Club delivers concise polymer subject learning that relates to industrial applications, which will help you with your consumer goods product development job function. Polymer E-Club provides the opportunity to know relevant content quickly concerning numerous polymer subjects, so you'll be successful on the job instead of being limited with book knowledge about fewer subjects. Let's discuss the figure on your screen concerning a horizontal injection molding machine. Going left to right, thermoplastic pellets are placed in a hopper and a screw moves the pellets through the heated barrel, and the flowing pellets are injected into a mold, thus the term injection molding. As the thermoplastic part cools, it shrinks, so more material is added to fill the mold cavity. A key feature of an injection molding machine is the reciprocating screw, which besides turning, also injects the molten thermoplastic through the gate and into the mold, and then the reciprocating screw moves back to acquire the next shot of material. The injection molding tool opens and closes, and we know that 20-second cycles are common when injection molding thermoplastics. Cooling channels are incorporated into injection molding tooling, and fluids like water are used to remove heat from the tool steel, which surrounds the molten and cooling thermoplastic. Ejector pins eject or push the part or parts from the tool, and we might see ejector pin marks on the underside of the part if you can get those subtle blemishes past marketing. Injection molding tools have a stationary or cavity side that is closest to the barrel nozzle and a moving or core half that opens during part ejection. It is most common for material to flow from hopper to barrel to gate to mold cavity, and upon cooling for the tool to open and eject the part from the moving or core half of the tool. Remember, we said thermoplastics will shrink with cooling, more for crystalline compared to amorphous thermoplastics, and by shrinking to the core, it is easy to eject the part from the core side once it is cooled. Designers manipulate part drafts so the part remains on the core side when the tool opens and the part is ejected. Injection molding parts are thin-walled, maybe 2 millimeters thick, where design creates the part details and complex structures. Lastly, the sprue and runners are ejected with the part unless a hot runner system is used to insulate the sprue and runners, and then only the part leaves the tool. However, hot runner tools are more expensive. Knowing the basics of injection molding and when best to use this high-volume process, that's working knowledge. Remember to like, subscribe, turn on notification, and even share if you appreciate the content. You can visit our website to learn more about our upcoming Polymer Applications course. I'm Paul Nash for Polymer E-Club's Ask Dr. Paul. Thanks for watching.